As of today, Earth is still the only place where we know life exists, and that's kind of insane when you think about it. Like genuinely, properly insane. We've sent probes everywhere. Mars, Venus, the outer planets. We've scanned distant stars, analyzed atmospheres, spent billions trying to answer one simple question. Are we alone? And so far, nothing. Not a single confirmed microbe, not even a clear chemical fingerprint of life, not even something that makes a scientist go, that's weird. Just silence. Complete, total, slightly unsettling silence. But here's the thing. When you really stop and think about the size of the universe, that silence starts to feel strange, not comforting. Strange. Because the universe isn't just big, it's stupidly big. Like, people say that all the time and it just kind of washes over you. So let me actually try to paint this picture. There are more stars out there than grains of sand on Earth. Not just beaches, everything. Every desert, every ocean floor, every single grain of sand on this entire planet. And the universe has more stars than that. And around most of those stars, planets. Hundreds of billions of galaxies, each with hundreds of billions of stars, each with their own worlds spinning quietly in the dark. So the idea that life only happened once, right here, on this one rock, yeah, that starts to feel unlikely, almost arrogant. So today, we're not going to Mars, we're not going to Venus, we're going somewhere far more interesting. We're going to the most promising worlds ever discovered, planets that might not just support life, but might actually be better at it than Earth. These are the super habitable worlds, and trust me, some of them are genuinely insane. Let's go. Okay, first stop, KOI 5715.01. Not the best name, I know. Sounds like a Wi-Fi password someone never bothered to change. But this planet might be the single best candidate for life we've ever found. It's about 3,000 light years away, which basically means we're not visiting anytime soon. But if we could somehow get there, this is what we'd see. A massive rocky world, roughly twice the size of Earth. Now that might not sound like a huge deal at first, but actually think about what that means. More surface area, more land, more oceans, more environments, more chances for life to evolve. And not just survive, thrive. Picture continents so large it would take over 100 hours just to fly across them. Ecosystems stretching for thousands of kilometers. Species evolving in ways we genuinely can't even begin to imagine. More land means more niches. More niches means more species. More species means a biosphere richer than anything we've ever seen here on Earth. But here's where it gets really interesting. It's not just the planet, it's the star. Our sun, it's fine. A decent star, doing its job, but it's on a timer. In about 5 billion years, it's going to expand into a red giant and probably swallow Earth completely. Game over. Full stop. KOI 5715.01, on the other hand, orbits an orange dwarf star. Smaller, cooler, but way more stable. These stars can live up to 70 billion years. 70 billion years. Just let that number sit for a moment. Life on Earth has existed for about 4 billion years. And look how far we've come. Single-celled organisms to cities, primordial oceans to space telescopes, from nothing to us, sitting here talking about other planets. Now imagine evolution with 10, 15, 17 times more time. We're not talking about just animals or plants. We're talking about possibilities we can't even conceptualize. Civilizations so advanced they make us look like ants. Technologies that would look like pure magic. Entire worlds physically shaped by intelligence itself. It's almost hard to wrap your head around. And then reality hits. It's 3,000 light years away. Even with the best technology we have right now, it would take over 100,000 years to get there. So for now, it stays a dream. A beautiful, humbling reminder of what might be out there waiting. All right, Let's get a little closer to home. Only 39 light years away, which in cosmic terms is basically next door. Welcome to the TRAPPIST-1 system. And this one is genuinely crazy because it's not just one planet, it's seven. Seven Earth-sized worlds, all orbiting the same star, packed so tightly together that the entire system would fit inside Mercury's orbit around our sun. Now really think about that for a second. 7 planets, all closer to their star than Mercury is to ours. And somehow, 3 of them are in the habitable zone. 3 chances for liquid water, 3 chances for life, 3 separate worlds where the conditions might be exactly right. That alone is already incredible, but it gets better. These planets are older than Earth by billions of years, which means if life ever started there, it's had a serious head start on us. Billions of extra years for evolution to run, billions of extra years for complexity to build, billions of extra years for something, anything, to figure it all out. Now, out of all 7 worlds, one stands out the most. TRAPPIST-1e. This one is special. It's slightly smaller than Earth, probably rocky, sitting right in the habitable zone. Some models suggest it could even have a thick atmosphere, maybe even liquid oceans sitting on the surface. But this system comes with a twist, a big one. These planets are most likely tidally locked, meaning one side always faces the star, permanently lit, permanently hot, and the other side is in permanent darkness, permanently frozen, permanently dead. One half burning, the other frozen. Sounds like a nightmare, right? But wait, because right in between those 2 extremes, there might be a narrow band, a strip running around the whole planet, a twilight zone where temperatures are just right, not too hot, not too cold. A place where liquid water could sit on the surface, where an atmosphere could hold, where life could not just exist, but potentially flourish. Now imagine actually standing there. You step outside, look up at the sky, and you don't just see a moon, you see other planets, huge, close, hanging in the sky like enormous glowing worlds. So close you could literally watch weather patterns forming on another planet from the surface of your own. Interplanetary travel in that system wouldn't be science fiction. It could be completely routine. A trip to another planet might feel like catching a weekend flight, skiing on one world, summer on another, all within the same system. It sounds unreal, but it's not impossible. It's just 39 light years away. Now let's talk about something a little more familiar. Kepler 452b, also known as Earth 2.0. Yeah, that name sets expectations pretty high, and honestly, it kind of delivers. This planet orbits a star very similar to our Sun. Its year is 384 days. That's only slightly longer than ours. It sits right in the habitable zone, and it's rocky. On paper, it looks like home, genuinely uncomfortably like home. But there's a catch. Actually, a couple of them. First, it's about 50% larger than Earth, which means stronger gravity. A lot stronger. You'd weigh almost twice as much there. Every single step would feel heavier. Running would be exhausting. Climbing anything would feel like a punishment. Living there long term wouldn't be easy. Over generations, life forms would probably adapt. Shorter, stockier, built for the weight. But there's a bigger problem lurking in the background. Its star is older than our Sun. And older stars? They get hotter, brighter, more aggressive over time. Scientists believe Kepler 452b might already be receiving too much energy from its star, which could be slowly triggering a runaway greenhouse effect, the exact same catastrophic process that turned Venus into a 465-degree pressure cooker where metal melts on the surface and nothing survives. So while this might be Earth 2.0, it might also be Earth too late. A warning more than a destination. And finally, Kepler 22b. This one is different, very different. Because this might not be a land world at all. It might be a water world, a true one, not like Earth, with continents and oceans and beaches. No. Imagine a planet completely covered in water. No land, no beaches, no mountains poking above the surface, no ground to stand on anywhere, just an endless ocean. One single global ocean stretching hundreds of kilometers deep. Think about what that actually means. An entire planet of water, and deep below the surface, total darkness, crushing pressure, temperatures near freezing, but also possibility, real possibility. Because life on Earth didn't start on land. It started in the ocean, near hydrothermal vents on the ocean floor, in complete darkness, under extreme pressure, in conditions that looked completely impossible. And it didn't just survive there, it exploded. So what could evolve in an ocean that deep, on a planet that old, with billions of years to experiment? Creatures glowing softly in the darkness, drifting silently through black water. Massive organisms moving slowly through underwater mountain ranges we'll never see. Entire ecosystems hidden beneath miles of ocean, completely cut off from the surface, completely alien to anything we know. A whole biosphere, hidden beneath waves. If we ever manage to send a probe there, what we find might completely change how we understand life, not just out there, but here too. So, 4 worlds, 4 very different possibilities. A planet with billions of extra years for evolution to run wild. A system where 7 worlds orbit so close you could watch storms on your neighbors from your backyard. An Earth-like planet racing against its own dying star. And an ocean world hiding secrets hundreds of kilometers beneath its surface. And all of them raise the same question. If life can find a way in so many different conditions, what are the actual chances that
we're really alone? Honestly, probably not very high. Probably not very high at all. And maybe we're just at the very beginning of finding out. So if you had the choice, which one would you go to? Let me know in the comments. I genuinely want to know which one pulls you in. And if you want to keep exploring worlds like this, make sure you subscribe, because this is just the start.